We'll continue with another probability tree example. A box contains 20 chocolates, of which 15 have soft centers and 5 have hard centers. 2 chocolates are taken at random, one after the other. So that's important because we're going to do examples later where we're going to take 2 at the same time and the answer is going to be different. 2 chocolates are taken at random, one after the other. Calculate the probability that both have soft centers, one of each chocolate is taken, and both have hard centers given that the second has a hard center. So the easiest way at this point to do this calculation is going to be to draw a tree to represent it. So we're going to start here with the probability of taking a candy and it having a soft center. Well, we know 15 have soft centers out of 20 altogether. And then we have the probability of getting a hard center is everything else, or 5 out of 20. Again, being sure that this is going to add up to 1. So now we've taken a soft one. What is the probability of taking another soft one? And we should see that that's now 14 soft that we can pick out of the 19 that are left. And the probability of taking a hard one now, we didn't take any, so we still have 5, but there's only 19 to choose from now. And our last branch here, we took a hard one. What is the probability of the next one being soft? Well, all 15 soft are still there out of the 19 that are left. And the probability of taking a hard, well, we had 5 to start, but we already took one, so that means 4 out of the 19 that are left. So there's our tree for all the possibilities of taking 2. Now, both chocolates have soft centers, so we want the probability of soft and soft. Well, soft and soft is the only way that can happen is along the top of the tree. So that's going to be 15 out of 20 multiplied by 14 out of 19, which is 210 out of 380. So that's the probability of soft, soft. One of each is taken. Well, that can happen 2 ways. We can have the probability of taking a soft followed by a hard, plus the probability of taking a hard followed by a soft. So you see the 2 middle branches account for that. So that's going to be 15 over 20 times 5 over 19 plus, where are we to? 5, so I'll take a hard first, 5 out of 20 times 15 out of 19, soft next. So that's this branch in the middle here. That gives us 75 out of 380, and you should realize that that means this is going to be 75 out of 380, which means 150 out of 380. And now it says both have hard. Well, we're going to do one more thing first. What is the probability of both hard with no conditions? So this is a different question. Both hard is the bottom branch, just so we've looked at all the possibilities. We have 5 out of 20 times 4 out of 19, and that's going to give us 20 out of 380. And the check, of course, 20 plus 150 is 170, plus 210 is 380 out of 380. So we've looked at every possibility. Well, the final question then, I'll change colors just so it stands out. Part D, both chocolates have a hard center given that the second is hard. So what is the probability of having 2 hards given that the second is hard? Alright, so what is the probability of having 2 hards given that the second is hard? Well, that is equal to the probability of hard and hard divided by the probability of the second being hard, which is the probability of that is 20 out of 380. That was that final calculation we just did. What is the probability of both of them being hard? Divided by the probability of the second being hard. And this is where we need to think for a minute. The second being hard happens twice. we can have the probability of picking a soft and then a hard, or the probability of picking a hard and then a hard. Both of those give us a hard candy second. So we're going to find those probabilities and add those together. And so in this case, that's going to be, well, we know this one again is the same as it's been every time. Soft and then hard, well, we did that calculation before, is 75 over 380. Add those together, we get 95 over 380. So the probability of the second one being hard is 95 out of 380. And if we do that, we end up with 20 over 95 as the probability of choosing too hard, given that the second choice was hard. We could do one more example where we found the probability of having two hards given that the first was hard. And that's a little bit easier because now we're doing still this, but now we just have to divide by the number of ways to choose hard first, and we know that quickly is 5 over 20 pH in the beginning there, and that will give us 80 out of 380. As you can see, the answer is the same. The probability of getting too hard doesn't change if the hard comes first or the hard comes second. The calculation is a little different, but the result is the same. And so that's the end of that solution.